Hello and welcome. Today we're going to look at vectors. So we're going to go through the basics of what we already know. So the first thing that we know is that a vector is a quantity with both magnitude and direction. Okay, so very important, it has a magnitude and it has a direction. Whereas a scalar, which is opposite to a vector, has only got a magnitude. So for example, a scalar can be 15 seconds. We don't say 15 seconds north or 15 seconds down, but a vector, okay, would be 10 Newton east, okay, or 10 Newton to the right. Okay, so how do we represent a vector? A vector is represented by an arrow, okay? The length of the arrow is the magnitude, the size, and the direction of the arrow is the direction of the vector. So if we look here at the bottom, we can see here that this arrow is to the right, okay? We also use positive and negative to indicate the direction of a vector. Remember, your calculator cannot take direction, so we convert a direction into a positive or negative. So positive we have taken to the right, and here we draw a vector with an arrow pointing to the right. So this arrow indicates the direction. Okay, left is negative, so here we've got a negative vector to the to the left. And if we compare the two vectors, their magnitudes are different, because this is 3 and that is 5. And if we look at the lengths, we can see that the top one is bigger. Okay, so when we have a vector at an angle in physics, we will use a protractor, okay, to get that direction. So you'll physically take your protractor and you'll put it there on the corner. Okay, you can put it outside or inside. Okay, and you'll measure that angle, and as we can see here, okay, a little bit out. Okay, so I'm measuring the outside now, 33 degrees. If you put it on the inside, okay, you're also going to get the same angle. So the direction, if it's not east or west, we use a protractor. So the word net, okay, means total, okay, and the resultant also means total. So when we want to calculate our result of all our vectors, net also means the sum of, okay, so the sum of all the vectors or the result of all the vectors is called the resultant vector. We don't really use net, but in the South African syllabus they use the word net sometimes. So the resultant vector is a single vector that has the same effect as two or more vectors together. The net vector or the resultant vector is the greatest when vectors are in the same direction, and the resultant vector is the smallest when vectors are in opposite direction. So let's look at what that means. Okay, we'll be looking at vectors in one dimension. We call them collinear because they are both, or all of them, are on the same line, collinear vectors. So for example, vectors in the same direction, remember we're going to have a maximum resultant force, is when there is two vectors in the same direction. So 5 Newton force acts to the right, and a 10 Newton force also acts to the right. So what we do is when we draw them, we draw the 5 Newton force to the right, we draw the 10 Newton force to the right. And when we draw the resultant will start from where this one starts and end where that one ends, and we draw the resultant. And the resultant is when I mathematically add my two vectors together. So I say f1, which is 5, plus f2, which is 10, gives me 15 to the right. And we said that when two vectors are in the same direction, we get a maximum resultant. Okay, now what does it look like if the vectors are in opposite direction? Okay, so if we've got a result, determine the resultant force or the net force when a 12 Newton force acts to the right and a 7 Newton force acts to the left. So what we do is we first draw the 12 Newton force to the right. Below that we draw the 7 Newton force to the left. Now why do I draw below? I don't want to draw on top of this line and then draw another line on top of this one. So we draw below each other, okay? And just makes it a bit easier. So when I draw my second vector, remember a vector is from where the first one starts, which is here. Okay, let me just redo that. From here, round about there to round about here. And what we'll see now is our resultant is there. So the 12 Newton force is bigger than the 7 Newton force. So my resultant starts where the first one starts. It ends where the last one ends. And then the direction is the direction of the biggest vector, which is this one. Okay, so how does that work mathematically? First things first, I need to choose which direction is positive. Now, it's always better to choose, well, it doesn't actually matter because we're going to use the sign, and the sign we're going to change back into a direction. So we chose right as positive. We made this a positive 12 and a negative 7, and our answer was positive, so our answer became right. If you use the other way, you'll just have a negative 12 and a positive 7. You'll end up with a negative 5, and that negative you will interpret as right again. Okay, so that what you choose as positive doesn't matter. A lot of people choose like the mathematical number line, the positive side to the right and the negative side to the left. But if the object is moving to the left, sometimes a car is moving to the left, you choose the left as positive. Okay, so you add the one and you add the other one. We always add vectors together. Then we substitute the sign of the direction, and the answer in this case is positive 12. And since right is positive, it is a direction right. So we replace the sign with the direction. Now, this can also be used for multiple vectors. So determine the net force when an 8 Newton force acts to the right, a 10 Newton force acts also to the right, and then a 25 Newton force acts to the left, and a 12 Newton force acts to the left. So what we'll do is we'll draw the first vector, 8 newtons to the right. Then we'll draw the second vector. Then we'll draw the third vector, 25 to the left. Then another 12 to the left. And now remember, when we draw our resultant, it starts where our first vector starts. So my resultant will start here, and it will end where the last one ends. And the direction will be in the direction of the majority. So it will go there and in that direction. Okay, and if I draw the resultant now, so here we've got 37 to the left and 18 to the right, and mathematically we'll see that our answer is negative 19 Newton, or 19 to the left. So what did we do here? We first used our direction. We use right as positive. So this is a positive 8, a positive 8, a negative 25, and negative 12. If you can see here, we always add our vectors together. It's the sum of all the vectors, or the result of all the vectors. And then we add the values with their direction. So it's a positive 8 plus a positive 10 plus a negative 25 plus a negative 12. That gives me a negative 19. and I interpret that according to my decision in the beginning, that that negative means left. So I can draw the way I did here, or I can calculate the way I did there, or sometimes they force you to calculate or force you to draw. Okay, so now that is vectors in one dimension, and everything we've done up to now should not be new to you. But what is new is what happens when we've got vectors in two dimension and we call them non-collinear. So when vectors are in two directions, the vectors are not in the same line. A vector triangle can be used to determine the resultants. So when the vector triangles are formed, mathematical rules can be used to determine the vectors or the resultants. Okay, so what do we mean? Let's look at it. Okay, when we draw the vectors, for example, the first method that we'll look at is the tail to head. I sometimes say head to tail. It's the same thing. Okay, so that is when we have consecutive vectors. So, or vectors that occur in a sequence. Okay, so this is a good method to use when there's a sequential moving. A boat travels 90 meters east and then 50 meters north. Okay, so what we do is we first draw our first vector. So 90 meters east. Then we draw our second vector, 50 meters north. Okay, and then the resultant, as we said, is from the beginning of the first vector to the end of the last vector in the direction, okay, where the last vector ended. Okay, so here our direction would look like that, and if we draw our vector, our resultant looks like that. So remember now, we cannot just add the 90 and the 50 because they're not in the same line. If it was 90 east and 50 west, we could use what we learned before. But the problem is now they are in two different lines. The one is vertical, the other one is horizontal. So we cannot simply add them together. And what we need to do is when we draw, we still just draw the one and draw the other. And I'll show you the mathematical calculation just now. Okay, so this can also be used for more than two vectors that take place. The resultant is the tail, from the tail of the first vector to the head of the last vector. Remember, the tail is like the butt and the head is like the tip of the arrow. And I always say that's how dogs greet each other. One sticks its head and the other one's tail. Okay, so tail to head or head to tail method. We draw the first vector, and we draw the second vector, draw the third vector, draw the fourth vector, and then from where my first vector starts to where my last vector ends, I draw my line to there, and I draw my arrow in the direction from where I started to where I ended. And when we draw our resultant, the resultant is from the origin to where the last vector ended, and we measure that line and we use a protractor to get this one's direction. So what would be the direction? It would be from the x-axis up to there would be 79 degrees or 78 degrees. Okay, your protractor doesn't go to one decimal space. Okay, but we'll look at that just now. Next, there's a second method that we can use. That's the parallelogram method, and it works for two actions that happen concurrently. Okay, the resultant is a diagonal of a parallelogram, hence we call it the parallelogram method, and that originates from the tails of the vectors, okay, to the common origin. Okay, so what does that mean? I have two vectors now. One is going here and on the x-axis, and my second vector is going on the y-axis. Now what I do is where vector 1 ends, I draw the same height. Okay, I draw from here the same height as vector 2, and where vector 2 ends, horizontally I draw the same height and I form a parallelogram. Okay, so what I do is I do that with a dotted line because that's not really my vector, and then from where they both started to where they would have met here, where those lines met, I draw my resultant. Okay, so here the two tails touch each other and the heads point away from each other. We make a parallelogram. So we take the same horizontal distance that we had here, okay, and we measure it from the tip of the second vector, and we take the same vertical distance that we had here, and we measure it above where that one ends, and that will form a parallelogram. And this one side or slide, it looks like a square, but most times it will form a parallelogram, and the resultant is from where their tails come together to where these dotted lines ends, and we draw a line, straight line in that direction. Okay, parallelogram method. Okay, so this is an example. For example, when two tugboats apply a force on a cargo ship, the one pulls, so here obviously here's my ship then, let's just say my ship is over here, and that one tugboat is pulling in this direction, 6,000 Newton at an angle of 30 degrees from the horizontal. Okay, obviously this is now from above. Okay, and 30 degrees from the direction of motion this way, and my other one is pulling 5,000 Newton 30 degrees below the direction of motion, and the result of those, okay, what I do is the same distance or the same force that I have for this one, I draw where the second one ends, vector 2 ends, and what I do is for the same distance here, I draw over there, same direction, and that forms a parallelogram. And then from where the tips come together over here to where these two lines meet, that is my arrow and that is my direction. Okay, so how do we calculate? That's the drawing part. How do we do calculations? Okay, so remember when we have we can use Pythagoras' theorem if it's 90-degree vectors. Now remember, a vector has a magnitude and a direction. If we go back to some of our previous slides quickly. So as we go look at one of the previous examples, the magnitude we measure with a ruler, how long the line is, and the direction we measure with a protractor, at which angle it is. So the angle is the direction and the length is the magnitude. So in order to calculate the length of the sides, we use Pythagoras' theorem, okay? And to get the angles, we use sine, cos, and tan. So how does that look? Let's see. Okay, so for example, we have a boat traveling 90 meters east and then moves 50 meters north. Determine the displacement of the boat. So what do we do to draw? We first draw the 90, then we draw our 50, and our resultant is there. So now that's how we draw it. But if we want to calculate it, we use Pythagoras' theorem. So this, because this is my angle, okay, this becomes my x value because it's horizontal, y value, and this would be my resultant or my hypotenuse. Okay, in mathematics we would call this our adjacent, our opposite, and our hypotenuse. So what we do is, if we want the resultant, we say r squared, or the hypotenuse squared, is the x value squared plus the y value squared. So it's 90 squared plus 50 squared square rooted, and that gives us the magnitude of our resultant force. So now we only have half of the vector. We only have the size. What we now need to do is to get the direction. So if we look at our angle again, we call this the adjacent. That's the opposite. That's the hypotenuse. I have the value of the adjacent. I have the value of the opposite. And using trigonometry, we know that tan theta is adjacent over opposite. Okay, so we look for the one, we memorize this. You've memorized this in math. Okay, tan is adjacent over opposite. Okay, or opposite over adjacent. So we place the opposite 50 over the adjacent. We're separating the tan from its angle. They divorce. So this is a divorced tan, -1. Separated from its angle to calculate the size of the angle. And that angle size is 29.5. So what we've done is we've calculated our magnitude. We've calculated our direction. So then the displacement is in 102.96 meters in a direction of 29.2, and we have our magnitude and we have our direction. Okay, and then that is only if it's 90 degrees, and that's what we'll do in IGCSE, but for interest's sake, if it's a triangle that's not at 90 degrees, we'll use the sine rule. Now, most probably you haven't seen the sine rule before, but how the sine rule works is if you've got a side and an opposite angle and another side, and you want to calculate an angle opposite to that side. So in this case, we're not using the C's. Okay, so you can use this formula. The side of A over sine of the angle A is equal to the side of B over the angle B. Okay, this is now when we want this one and we have that side. We calculate B here, or you flip it around if you have, if you want the angle like we initially wanted. You have the angle of A, you have A, you want B sine of B, and you have the length of B, and then you can determine the angle. Okay, so this is not in IG, but some of you guys might find this interesting. So we can mathematically and calculate anything that's not a triangle. So if we think back at our other slides, this would typically be a case where I would kind of use the cos rule. There's no 90-degree angle here, so I can't use Pythagoras' theorem. So if I wanted to mathematically calculate the resultant, I have to use the sine rule. Okay, but in most cases when it's not at 90 degrees, we will be drawing and not calculating. I hope you understand, and if you've got any questions, please feel free to ask me. Have a nice day. Goodbye.